So I'm just sending the others in case somebody wants to join, so he can do it. Okay. So yesterday we have already finished talking about, not yesterday, the last week, sorry. We talked about Java packages, and the main part that we have already started with it's about inheritance and polymorphism and Java inner classes. Especially the inheritance part, when we talked about how we can extend from a class, and the concept of inheritance that we can create a child class that can inherit all the methods and the variables that are existing in the upper class or the parent class, plus we can add more variables and methods. And this is one of the powerful concepts in OOP, that you can define a general parent class that you expect later you will have a set of classes that they will share these common parameters and methods, plus more specific parameters and methods that will be specific to the child one. So we can, rather than having the common code, when I said common code, I mean that the common variable and common methods, going and implementing them in the many classes, which is the child classes. So we can put them in the main class or the parent class, and then we can just extend, and we can add the more specific methods and variables for the child class in this. Without having this, we can't make any reuse of the code, which is one of the main advantage of OOP. So using this, we can reuse the code. And we talked about polymorphism, and we said that the existing method can be overridden by the child and also can be overloaded. And we talked about what we mean by, when we talked about overloaded, we talked more about the child, but we can make also overridden within the same class in this case. And this is what we mean by polymorphism, which means can have the same method can have different behavior if we have an inheritance, for example, or if we need to have the same name but with different behavior. Today, we are going to talk about two main concepts that somehow, after we finish this, you will have the whole concepts concerning inheritance and OOP main concept. The next step will be in this course, how we can apply this concept using different data structures and to have a more applicable exercises in this case. So the abstract classes and method, I think that we have already discussed this when we talked about modifier. We didn't discuss it brief, we just said what we mean by the abstract class, but we didn't go deeply in it. Gerson, Bryden, and Jason, do you have any question from the last lecture before we start this?
I think I'm good.
Perfect. So, perfect. So concerning assignment 1, we have already published this, and we should have assignment 2 this week. And also I should publish the grades within this week, or by the end of this week. So just this is for the people that are going to watch this video to let know about this. Okay, so let's start with Java abstraction. The concept of abstraction, why we need abstraction. This is a real life example, but yeah, when we talk about programming, we are expecting later that this software, to build this software to solve a problem in the real life, or to manage the information or the operation for a specific application in real life scenario. So you have a car, and this car can have different parameters. And these different parameters, some of them will be interested for different people, not at the same level. For example, if you are the owner, you will go ahead, you are more interested in information about car description, service history, the mileage history. If you are a garage, you will be more interested about license plate, work description, billing info. If you are a registrar agent and you're talking about registration agency, so they will be more interested to know about the current owner information, vehicle information. So all this information about the car. However, each part of these entities will be more interested to know a special information about this car. And sometimes it's not only about interest, also about privacy, about when you are going to implement such kind of an application, you should consider in your implementation that, okay, this person can see this, and this person can see this, and this person can see this. So you need to have such kind of access control for such kind of a data. So when you are going to implement this real life case scenario, I don't know if you have already started with some, if you all who's watching this video have already started with some courses concerning analysis and design software. Because when we talk about analysis and design, we start collecting requirement of any application. And then we will go with the use cases till we will have a class diagram. And this class diagram, later we are going to implement it. So based on this example, we can see that there is a function named display information. But this function can have different output whenever it is going to be called by different object. Like the garage person is going to display an information not the same like the owner one, not the same like the registrar one. So each one of them is going to see an output from the same method but different output. In this case, this method, we name it display information. It will be an abstract method. Because this method, which is an abstract, we can't start with an initial implementation in it. So we know that there is a method should be named concerning display information, but we can't start with a special implementation, one-side implementation behavior. What is the output or the return of this method? So since we have this abstract method, and we will have more abstract method maybe when we are dealing with different classes. So we need to create an abstract class for this car. And this abstract class can have some methods that they are not abstract. And these methods, they are not abstract. In this case, all different entities or object can call these methods and get an output. And there are some methods, like here display information, maybe for security issue, more for privacy issue. We will not have an implementation for this. And later, each object that comes from a special class will have its different behavior or implementation in this case. So in Java, to do this abstraction, which means that you know that there are some methods that they exist, but they will have different behavior, and you can't have a default behavior for them and then later you change this behavior. This is why we are going to define this as method as abstract, and this can be found this abstract method either in abstract classes or interfaces. We will talk more during this lecture today about the difference between this and this. However, so far, I want you to know that The interfaces, it 100%, we can say it is allow abstraction, which means that all methods in interfaces, they are abstract. So far, the word abstract, no implementation, no behavior. Just this method exists, but without any behavior implementation. However, the abstract class, it can have abstract method or also no abstract method, plus there are non-abstract methods there will be. So this is why this is the main difference between interfaces and abstract class. 100% there is abstraction in the interfaces. In the abstract classes, some are abstract, some there are non-abstract, which we name it concrete methods, that they have the implementation, and then abstract methods that was without implementation. Here it should be corrected here. Abstract method without implementation in this case. This, we talk abstract method without. This should be without here. So let's start with the abstract classes and methods. So, sorry. Abstract classes and methods, as we have already discussed so far, it is a restricted class, which means that whenever you define it as an abstract class, you can't create directly an object from it before you inherit another class from it. Why you need to inherit? Because it has some abstract class, and this abstract class is without behavior. So if you created an object later from this abstract class and you call this method, so you are calling a method without a behavior. This is why if it was defined as an abstract class, you need to have later an inheritance from it, and you can't create a direct object from it. Even though it can have a constructor, but you can't have because this constructor can be used later by the inherited child, but you can't create an object directly from this. So
I have a quick question.
Go ahead, Kirsten.
So for the abstract method, it's like a general name for a method, but it's different for every class that inherits it.
Yeah, so when we talked about a method in Java or any programming language, what is a method? It's a method, it has a name, it has parameter, and it has behavior or the implementation, yes?
Yes.
So when we talk about abstract class, you define a method, you give it a name, and you can define also the parameter, but no implementation, no behavior.
Okay, so for an abstract method, it can have the different classes that inherit it. It can have the same parameters in each class, but a different implementation depending on the class.
Yes.
Okay.
And they can have different parameters also.
Oh, they can. Okay.
So now here, for example, when we talked about here, display information. So display information, if we have a class, we name it car. So the display information in this class, it has no implementation. And later when we will inherit different classes from this, we can have different behavior, different implementation. We'll see a different example. Let's take this example now. So here we will have an abstract class animal, and there is an abstract method, we name it animal sound. And there is non-abstract method, which we name sleep. So there are two, one abstract, one non-abstract. So if you are going to later to create an object like here, this will not work. We'll get an error because you can't create an object directly from a class that you have already name it as an abstract one before you inherit. So before you are going to inherit another class, and then you will create object from the child class. And using the child class, if there is an abstract method in the abstract class, you have to implement it. It is a must to do this. So in here, in this example, we can see that we have here the abstract class. So as this is abstract method, and this is non-abstract method. Here we have a child class. As we discussed the last time, we use the extends. And then we will have another class name, we name it animal. Sorry, it's a class name that we have already here. So we extend this. And then as you can see in this class pig, so in the class pig, it has already sleep one, since it inherited it from here. And also it has to go ahead and make implementation for this method. By this is make this implementation, which means that this method will print out the sound of the pig in this case. It is a must when you will inherit here to implement the abstract class. And as I said, you can't go directly and create an object from here. Now we can create an object from pig. Here in this main class, we can create an object from pig. We can then create this object, and then we can call the two method. The one that you have already re-implemented it and the sleep method. Let me show you this here. You can still see my screen, the code, yes? Just to be sure about this.
Yep.
I'm obsessed now about this. Okay. So, yeah, by the way, there is a note I have to give it here. So if you create a public class, the file where you are going to save the class, it should have the same name as the class. So this is an important one. You have to consider it when you name your files. You can have more than one class in the same file, but there can be only one of them public one. This is also another note. But normally I prefer that if you don't have inheritance or inherited classes, so each class creates a file. It's better in your code how to organize it. And normally I will go that the main method I put in the standing alone class, whatever you can name it. It is just kind of unorganizing the code. So I can have the main method here also, but it's better to do it in a standing alone class. But again, if you have just, this is not concerning what we are discussing today, but because I received some email from the student about the error that they have already received. So if you have a public class, it should have the same name like the file. For example, here, this is a public class. So the file should have also main. I can name it another name in this case. If it will not be public, I can name it another name. Returning here, let's return to the code here. So we have here in this animal one. Let's close this. So the animal class, as we said, it is an abstract method. We name it animal sound. There is concrete non-abstract method. There is already implementation. We create another class. We name it pig, extend animal. And then since it is an abstract class, we go here to the abstract method and make implementation for this. So as we said, an abstract method, it means that there is no implementation. So here I make implementation. So I define a behavior for this. The behavior said that system without println the pig says we whatever it is. So now in the main method, I just have, this is for the next example. I just prepared here. So in the main method, I create an object from the pig, not the animal one, and then I can call the method that for the animal sound, because since I have already make implementation for this here, and also here it is. And then I also call another method that I didn't declare it here again in the pig. It's already being declared in the abstract. And this is one of the main difference between abstract and interface, as we see. So in the abstract, we can have a non-abstract, which is a concrete one. And since pig extends this, so we can use it and call this, we can do it here. So if we run the program here, we should get the output of the two methods. So here, if we go ahead and so the first method, it should have an output. The pig says wee. So based on this is a method we talk about returning here. This is the animal sound, since we call the animal sound first. And the sleep one also as a behavior ZZ, so it will also we have here ZZ. So this is how we can use the abstract class, and how we can call the abstract methods after we implemented it using the child one. This is why the last time we talked about inheritance before we talk about abstract. And since we need to have abstract class, as I said at the beginning, since we need some methods to be abstract one, because we don't define a behavior for them, and they can have different behavior based and different inheritance later. So let's take another example when we have not only one class can extend the parent class, we can have two classes can extend the parent class, and in this case, each one of them can have its own implementation to the abstract class in this case. So we have here class, we name it shape. So it is also an abstract one. Abstract. So it has an abstract area, and this is here, this is somehow logic to have this, because when you talk about shape, the implementation of the area will differ according to different shapes later. So no need to here. We know that all shapes, they should have an area. However, each one has its own way to calculate the area. So it should be abstract here. So another abstract method that you can use it from string to string. So as you can see here, I add this example to let you see that you can have a constructor for the abstract class. However, you can't create an object. So this constructor just that can be used later with the child classes in this case. However, you can't use it directly from an object. You can't go ahead and create an object from this abstract class, because as I said, you can't create an object from abstract class. You can create an object from the child class after you implement the abstract classes that was defined in the parent class. So here, this is a concrete method, so it is non-abstract. As I said, since we have an abstract class, we can have non-abstract and abstract method in this case. So, and again, if you are going to go ahead and do it, so I will show you the code here about this, because here, yeah, here. So in the shape one, there is a code shape that we have already discussed. So, and then I make another class, I name it circle, extend this. You see here in the circle constructor, I call this super, maybe we didn't see it before. This is a good example to see it here. Super, which means that I call the constructor of the super class. So I can call it here if I define a constructor in the parent class. And then since I have here an abstract method, name it area, I have to override this abstract method. So I said the area for the circle can be pi times mass to the power radius. There is a mass here, we can use it here. And then I also implement to string, just this is what is expected to the string to return. So now, as I said, it doesn't mean that only one class can extend this abstract class, can have different classes extend. This is what we name it, if you remember, hierarchical inheritance, which is you can have different child to the same class. Even though it is an abstract one, we can also do it for this abstract one because it's a class. So we have a rectangle, and this rectangle, if you go to the area now, so it has another definition to the area, returning length times what? Here, the definition was returning mass times pi times mass power radius 2. So this is a good example how we can have different behavior for the same abstract method. We know this method exists, but we can't. Here we can define a special implementation for this, and later any child can override for this because there is no typical implementation or default implementation for the area, because each shape will have its own area. So it is illogic, meaningless to have a default implementation for this method. This is why we need to have it an abstract. And since we define it as an abstract, we are going to define the class as an abstract. The same way, we can go to the main method here. And I add the code here. I'm showing you the code today here in order that maybe adding just the code in the lecture without see how we can write here in the editor. I got some question from some students. This is why I'm doing it today like this. So
I have a quick question.
Yeah, let me just run it. I will answer your question.
Okay.
So now I create, you see here, I shape new circle and new rectangle, and then I make a print out two string to print out the area as I define this one. So if I run it now, so I guess this is shape constructor called shape constructor. You see why? Because according to the code here, I call the constructor here, upper one here, which say here shape constructor, and I also call different method within this constructor. So, and then this is the whole output as we have already expected. This is for the rectangle one, and this is for the circle one. Go ahead, Kirsten, you have a question to me.
Yeah, so if you're creating a new object from a class that inherits an abstract class.
So let's use this. We have a parent and we have a child.
Yeah, a parent and child.
Okay.
So the parent's constructor, it will only be called when you have that super keyword in the constructor of the child?
Yes.
Okay.
Because super will represent the super class.
Okay.
So since we have a parent and child, what will be the super class in this case? It will be the parent one.
The parent. Okay, so if you didn't have those super classes, then that shape constructor called would not be.
There is two keywords. Maybe there is no chance to. There was no chance before to see them, but we will see it more. There is two keywords. You will see it in the Java here. This and super. This will resemble the active class where you are. Super will resemble the super class, in this case, which is the parent whenever we have inheritance.
Okay. Sounds good. Yeah, that makes sense. Thank you.
Yeah, sure. So now let's now start with the Java interface. The Java interface, as we said at the beginning of the introduction, it is similar to any class, so it can have a methods, it has also variables. However, all are abstract. So if we are going to define the animal as an animal as interface, not as a class, so in this case, we will have here, you see here, all are abstract. So both methods are abstract. And if we have a variable, they are going to be static and final one in the Java interface. If there is a variable, we will see it. We'll talk more about this. So now if I define it as an interface, not as a class. Here, when it was as a class, we go ahead and use the keyword extend. This is a child for this in this case. However, if you have an interface, we will not use the word extend because this is an interface. It's not an abstract class or a class to extend. We will use the word implements because that we believe all methods in this interface need to be implemented. So here, when we said implement, I have to go to the abstract classes that I have it here. If there is an abstract, how, and then go ahead and define them and go ahead and do it for them in this case. So also, by the way, here there is the run method. I should also implement it here in this case, since both of them, they are an abstract one. So I have to do it here. And then I can also have my own method that I will define it here in this case. So again, as we did before, we can create an object from the, I will not name it child class, I will name it like the implementer one, because it's not anymore use extend, it use implement. So like the abstract one, we can't create an object from this, we cannot. So in this way, we can create from the class that had already implemented this. And then we create a new object from this. And then we can call the method after we have already, if it is a concrete, we can include because it's a method that is related to this class. If it is a method that was abstract in the interface, we can call it after we implement this method in this case. So if we are going to make some observation concerning Java interfaces, they are like abstract classes. Interface cannot be used to create object, so we can't create an object from them directly. All interface methods doesn't have a body. The body is provided by implementing class. All, not like the abstract one. On implementation of interface, you must override all of its methods. This is why I said also one should be override here. Interfaces are by default abstract and public. So either, so why it should be, for example, then because later any class can make implementation for this. So by default should be public, that any class can go and make implementation to this. Sorry, I want to talk about methods for them. And attribute, as I said, the attribute should be static, final, and public. And this is why rarely we use, we define a variable in the interface. If we define them, they should go to be static and final. And you know that when you talk about static and final, the value cannot be changed later. So if there are some variables that you see that you need to assign a value that they will be unchangeable, you can define them in the interface. If not, there is no need to define any variable in this case. You can just define abstract method. Here, it cannot contain a constructor. In the abstract, we contain a constructor, but we can't call it directly. We can call it from the child class. And then there, in this, the one that we call from the child class, we can include more, if we need more implementation to it, But here in the interface, there is no constructor exist. In the abstract, since it is a class, it can have a constructor, but we can't directly call it. We can call it from, as I said, from object from the child class. But in interface, there is no constructor. Okay, now, why and when to use interfaces? So sometimes, yeah, here this reason, it is, we can say it for both, for abstract class and interfaces, to achieve security or privacy. So some detail you can hide it because you can define the method, but you don't define the behavior, and then you can implement or define the behavior in different classes. This is the same, let's say, feature. We can see it in the abstract classes and the interface. There's a common feature between both of them. However, Brainy. So the last time, Brainy asked us, do we can have a multiple inheritance in Java classes like this? We said, do you remember what we said? Kerson or Braden or Jason, do you remember what was when we talked about
You said
classes?
No.
We said no. So we said, no, we can't do it. But now the interface will solve the problem. So using the interfaces, we can have this multiple inheritance. It is maybe the word multiple inheritance. It is not a very accurate word, but in this case, we can have more than one interface can be implemented by the same object. This is, we can't have it if we have a class. So if A is a class and B is a class, this is a class and this is a class, C cannot extend both of them, and we said why. Because we said that suppose that X have a method, A have a method X, and B have the same method X, and here the behavior of X differ from here, so it will be ambiguous and confusion, and it will be confusing for the C, which X implementation it is going to inherit. This is why this is not allowed. However, since we are talking about interfaces, and these interfaces will have a method, but each method there is no implementation for it, so there is no ambiguity. It will be happen here in this case. So this example, for example, you will have a first interface. We have a my method, and here another interface. We have my other method, and they can have also the same method, because since this method has no implementation, so it will not make any confusion in the child one. And here you can see demo implement at the same time two interfaces. We can say here, for example, extend like this before, this two one if they are classes at the same time. So and we can say that we can say that A extend B and B extend C. But we can say A extend B and C like this. But we can have hierarchy A, B, B, C. But we said, but we have already again revised this today. But here we can say that implement list of interfaces at the same time. Just we can separate them by comma, like we did here. And in this case, in the demo class, you are going to implement the whole abstract classes and interface as we did here. So we go to the my method and the other method, and then we write the two code here. And then in our main method, we can have as its main class, and then we create an object from this demo one. And in this object, we can call this method and this method in this case. I think I have already, this is also mentioned here. Let me double check. Yeah, here I have it here. This is multiple interfaces. I name it multiple interfaces. So this I have interface 1, interface 2. I have this class. Again, if this public class, I name it public, so that file should have the same as the public class. But since I didn't public, so it is a default one. This, so I can name the class as a file another name, and then I make overridden for the two methods. And here in the main method, I declare this object and code. So if we run this program now, so here, this is the output of the first one, some text, and this output of the second one is some other text, as we overridden here. So let's make a comparison between both abstract classes and interface. So the type of the method, based on the level of the type of the method, interface can have only one abstract classes, only abstract classes, abstract methods. An abstract class can have abstract and non-abstract. But there is a note from Java 8. So before Java 8, which is JDK 1.8 that we're talking about it, this is starting Java 8, an interface has an implementation for a method, but with a condition that this method should be default and static one. Again, since before Java 8, all interfaces should have only abstract method. But in Java 8, you can define in an interface a default and the static method. Since it is static, so this method is not going to be overridden later. And it has a default. Sometimes maybe you will have an interface and there is a method, is not going to be changed by any class that is going later to implement this one. In this case, it should be default and static one. Again, this was an optional one they added in Java 8. Before it was. So if you have a JDK that is going to compile your Java file and it is less than Java 8 one, so it will not accept to have a static default method in the interface. Type of variables. Type of variables, we have an abstract class can have final, non-final, static, non-static variable, all can be included in the abstract. However, in the interface, we can have only static and final variables. This is very important. So in the interface, we can have only static and final variable. Implementation. Abstract class can provide implementation of the interface. Since an abstract class is a class, so any class can implement an interface. So this is why abstract class can provide the implementation of interface. An interface cannot provide the implementation of abstract class because it is an interface. So it cannot make extend or make implementation. So an interface, the other classes can implement this interface. However, when we talk about abstract class, it can provide implementation of this interface. Multiple implementations. Multiple implementation interface can extend. This is what we can extend another Java interface only. So as we said, it can't make extension for an interface can make extension for another one. Can extend another Java and implement multiple Java interface. So they are somehow similar to each other, but we talk about more multiple implementation. So an interface cannot implement any class, but it can deal with another interface only. However, the abstract class can implement the multiple interfaces like other classes as we did here. This was not an abstract, it was a normally class. And also the abstract class can implement multiple interfaces, and also at the same time can extend another Java class. This is if we are going to make the comparison between abstract class and interface. So now the question was said, okay, when to use this abstract class and when to use this interface. So since when I'm first, if I'm searching for abstraction, so I'm interested to have abstraction. So since I'm interested to have abstraction, so I have two choices, either to have it using abstract class or have to using interface. So the question is, again, I need abstraction because maybe I will have some security and data privacy and behavior, and I have different behavior, and I don't want to know some inheritance object to know about the behavior of other objects. So this is a main reason for abstraction. So again, I can do it by interface and abstract. So now when I have to use abstract and when I have to use an interface. So this is some hints that consider using abstract classes if any of these statements apply to your situation. If any, it's applied to your situation. So in the Java application, there are some related classes that need to share some line of code and then can put this line of code within the abstract class. So if you have some classes that they want to share line of code, which means that there are some methods that they all are going to use it. I'm not talking about abstract method. And there are some data or some methods you need to have security control or privacy control on it. So if there are some part that they are going to share it, which means that the same implementation, they have to share it. In this case, we need an abstract class because we can do this using interface. Because if you go to the interface one, we can share an implementation. All will be in this case all will be abstract one. The other point you are going to use this abstract classes is you can define non-static and non-final attribute. So if you need to share also in the parent class some variables, and you know that all the child need this variable, and later they are going to change the value for this variable. So in this case, no need to use the interface, because if you use the interface, it is a must all variables to be static one and final also. So their value cannot be changed later by the classes that are going to implement the interface. So now when we are going to consider interfaces in this case. So if you need total abstraction, so there is no implementation of any behavior you want to share it with any inherited classes later. So total abstraction. A class can implement more than one interface. So if you need a multiple inheritance, since the abstract class you can do it, as we have already discussed. So we need to have interfaces in this case. You want to specify the behavior of particular data type, but are concerned about how to implement its behavior. So as we said, so there is a particular data type that you want to define its behavior or its type that will be static, and final one, it will never be used later or never be changed. So in this case, we have to go to the interface. I think it's clear to you when to use interface and when to use abstract class. And again, when you go to some, let's say, analysis and design courses, really in the real case scenario, when you start collecting requirements for a software, you can know that this requirement I have to create an instance, an interface that will resemble this set of requirements, or a class that resembles this set of requirements. By the way, I can see that there are some programmers, they will not take care for this. And again, arranging your code in a good way, it's very important to have a nice, well-organized code. Because when you start coding a software, you should expect that many updates will come later. And also, many people later is going to work with this code. So it's not a long lecture today because I just want to finish the interface abstraction part. And as I said, starting the next lectures, we are going to talk about more linked lists and different data structures that using all inheritance, polymorphism, encapsulation that we have already discussed so far, we can see how we make a complete real example using different data structures, like not only the normal array. We will talk, I know that some of you they are not familiar with the Java one. So when I start talking about more about data structure, about that we can use it, I will go step by step to consider different data structure. And also in this course, I think we are going to talk about Java threads. But if you are going to talk about data structure and threads, I first have to finish all concerning polymorphism, encapsulation, and inheritance, because this talk more about the structure of the software, and the other talk about more about the usage of the code and how different implementation using different data structure we can use it later. We will see it later during the course. So guys, are you interested to have a group work exercise today? Before I will tell you what is a group exercise.
Yes.
Perfect. So like always, we will go to another room. I will be with you, and then we'll be back here to discuss the solution in this case. So I will stop recording now and go to the room, and then we'll be back here, and then we make another recording in this case. Perfect. So let me stop the recording here now. So now we can see my screen, yeah?
Yep.
So let's first discuss again what was the requirement, because we have already discussed this in the room, so it was not recording. So we need to rediscuss the requirement of the question. So first, write an abstract class shape. So it has an area and parameter, and then write a concrete subclass rectangle. It had a width and height, and then write an interface. We name it resizable. It has a method resize that will take double and then change the shape dimension by factor of x. Then in the main method, we have to create an object from a rectangle. And by the way, it's not mentioned here, this subclass is going to extend the abstract class, and at the same time it's going to implement the resizable interface. And then we are going to print the area and parameter before we calling the resize function. And then we are going to print again the values after we call the resize function. So Kirsten, I will stop sharing. Can you share the code that you have already finished?
Yeah, for sure. 1 second here. Okay, so this is, I'm just going to copy this into my compiler, since the stuff in my compiler is a little old.
Okay.
All right.
Yeah, there is a way that you can zoom this to see it.
Let me check. Is that better?
Yeah, it's better.
Okay, so I'll start from the top. So we have our main class here.
No, don't start from the main method. Let's keep it to the end. Okay. Start from the abstract class, then interface, then the rectangle.
Okay, so starting from the abstract class, I'm creating an abstract class called shape. I'm inside the abstract class. I have two abstract methods of return type double. So when you call them, they're going to return a double called get area, and the other one is called get perimeter. And then for my interface, I called it resizable, and I made a public abstract method of return type void. Since it's just resizing, we don't need to return anything from it. It just is serving some sort of purpose. And it has a perimeter of double x, and that's the factor of which your width and height is going to be increasing by. And then this is our class, our subclass that implements the interface and also extends the methods of the shape. I gave it two doubles, so two attributes, width and height. Then would it be initialized or just defined the method?
Implement.
Implement. Yeah, I implemented them
into.
Yeah, I implemented the abstract methods into the subclass. So the get area is going to return the width times the height, and the get perimeter is going to return the sum basically of its sides. So 2 times the width, since there's 2 sides of the width, and then plus 2 times the height. And then this public void resize is just the implementation of the interface abstract method. So this is basically supposed to resize the current width value. So it's going to be this dot width is equal to this dot width times the factor of resizing. And then the height is going to be the exact same thing. So it's basically going to be changing the values of the width and the height in with respect to the value of x. And then the this public void set dimensions is a method that is unique to it wasn't inherited. This is I guess native to this class. It didn't get it from anywhere. So I'm just creating a public void set dimensions. So void so that it's not returning anything. It just has a purpose. And this is basically just to initialize the width and the height. So this width value perimeter is this height is going to equal the width, or sorry, the width is going to equal the width perimeter or parameter, and the height is going to equal the height parameter.
But I think this you can create a constructor for the rectangle, and you can pass this to the constructor.
Yeah, we tried that, and we had troubles with it, so we just went with this. But yeah, we probably could have done that. Yeah,
this is what I think it will be better that in order not to create an object, then we call this function to assign the values, so we can assign the value in the same time when we are creating the object.
Yeah, we tried it, but I think we did something wrong. We couldn't figure it out.
No, don't worry. I will show you my code later after you finish.
Okay.
But perfect. But you have already done perfect. I'm very happy to see this, that you can understand the whole concepts about how to create an abstract class, interfaces, and also the old concepts concerning to create different methods for a class and make. Okay, go ahead. Let's go to the main method now.
All right. So our main method here, we're creating a rectangle object called myRectangle, and then we're basically initializing the dimensions, myRectangle.set dimensions to width equals 2 and height equals 3, and then we're printing out the area of the rectangle is, and then it's going to be plus, so it's like concatenating, is that what it's called? I'm pretty sure. myRectangle.getArea, so it's going to print out the area. Since this is return type double, so this method is going to return the area, and the same thing for the perimeter, it's going to return the perimeter, and they're going to resize both of these dimensions by a factor of 2, so it's going to be multiplying 2 by 2 and 3 by 2. And then it's going to be the exact same thing as what this is doing, except that it has new area, new perimeter, since it has new dimensions. And that's it.
So is it runnable?
Yes, but I can't run it here. Do you want me to?
Okay. No. You have already. We have already run it when you were in the room. So let me show you my. It's almost the same, but there are some a little bit changed. Let me show you my solution.
Okay.
So here I just make and organize the code in a way that I create a file. I name it shape for the class, for the abstract class. It has get area and get all further are from this method, and then I make resizable as the interface. Now in the main class, I create another class, a class rectangle. Again, if it is the public one, the file should have the same name like the public one.
Sorry, but I can't see your code. I can't really see your face.
Yeah, I don't think you're sharing your screen.
Really? That's good that you told me. So what about now?
Yeah, no.
You can see
Yeah, I
it?
can see it.
Yeah.
So okay, so let's repeat. So I organize the code in a way that I have a file for the abstract class, as you have already done it, but I created a standing alone file, another file for the interface, and I have a file, I name it main.java. If there is a public class, the file name should have the same as the public class. And I include the rectangular class here. So extend shape, implement resizable. But since this high and what it will be for this shape only rectangle, so I make it a private one because I expect other shape, they have their own dimension. And since it is a private one, we need to have a get public one to access them.
Oh, okay.
Here in the main class. So this, and as I said to you that you can for the class rectangle, in the constructor, you can pass the dimension. So here, when I create an object, in the same method, which is a constructor creating an object, I can pass the parameters, which is 2 and 3.
Yeah.
And then I implement the abstract 2 classes and also abstract method, in the abstract classes, and the resize one, which is from the interface, and I'll also make implementation to it, which is taking x and multiplying the high and what's by x. And now, if I will go to running our software now. So here the area was 6 and the parameter was 10 before we make a resizing, since it is 2 and 3. After resizing, which is here. After resize by 2, so it was 24 and 20 in this case.
Perfect.
So, any question for today?
I think we're good.
Okay,
Yeah, we're good.
perfect. So we finished the main part in the course concerning what we mean by classes, inheritance, polymorphism, encapsulation, abstraction. Then next we will start how we can use data structure within this inheritance environment. Since we finished the first month, like I always do with different courses, I will send you a survey that this is not only for the people who are here, for all people who are going to watch this recorded video and receive the email. So your feedback is very important. It will be anonymous one, especially since it is asynchronous online. There is no communication maybe with some people that I can get their feedback. Go ahead and write your own feedback. The survey will take just 5 minutes. Any question? I'll be happy to hear and also get your feedback. Okay, guys?
Okay, thank you.
Oh, I
Take
have
care.
one more question.
No, go ahead.
How many points are we getting, me and Jason? Probably
No,
just
I'm
5 or
giving-
something?
Yeah, always I will give you
I had
+5.
to ask. Okay.
No,
Awesome.
+5. Yeah,
Awesome.
I will add it to the Excel. I have already shared an Excel. I mentioned all your names in this.
Yeah.
Oh, shoot.
Have you already received this email? So
No,
I will
not yet.
update it. No, I have already sent an email about it.
Oh, okay.
I added per week who got the points or how many points he has already received.
Nice.
And I think there is a week you get 10 because you can double check the Excel sheet that I have already shared with you. Jason, you received it, yes?
Yeah.
So careful.
Okay, I'll check my Outlook.
Yes, check the email and you can see it. And I will update it with today.
Sounds good. Thank
Okay.
you. You as well.
Okay.
Bye-bye.